Hi, in this video we're going to expand binomials by using Pascal's triangle. So this is a binomial, right? It has two terms. Binomial means two-termed expression. So if I take the square of this binomial, then I'll have x squared plus 2xy plus y squared. If I take the cube of this expression, then I'll have x cubed plus 3x squared y plus 3xy squared plus y cubed. Now, notice that we have 1 here, and then we have 2 here, and then we have 1 here, whereas in the cube, it's 1, 3, 3, 1. And if I go with the fourth power, now I can write this quickly like x to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the power of 4. Now, this is not a memorization. It is just that I know the coefficients. So it's 1, 4, 6, 4, 1. And I know that the x term will lose the powers 4, 3, 2, 1, and it's going to be x to the power of 0, whereas the y term will start with y to the power of 0 and y to the power of 1, 2, 3, and 4. And I know the coefficients from Pascal's triangle. Now let's see how the Pascal's triangle work. So basically, Pascal's triangle is a triangle of numbers starting with 1 at the top, and then both sides you put just 1 again. So this second row is basically the coefficients of the binomial x plus y, right? And then you go on, you keep on writing 1 to the beginning and to the end, right? But for these two, you just write the sum, because what happens is when you expand x plus y squared, right, you end up with x squared plus xy plus xy plus y squared. And what happens is you add and say this is 2xy, this is represented in here, right? So we go on and we start with 1, and then you add these two, getting 3, 3, and 1 again. And then you keep on going. It's 1, 1 plus 3 is 4, 3 plus 3 is 6, 4, and 1. And then you're going to go like 1, 5, 10, 10, 5, 1, and so on. So basically, if I write these down, it's going to be x plus y cubed. These are the coefficients of x plus y cubed. And these are the coefficients of x plus y to the power of 4 and x plus y to the power of 5, and so on. You can extend this triangle up to infinity, right? There is no limit. So the coefficients of the expansion come from the Pascal's triangle with the relevant row. If I'm expanding, for example, x plus y to the power of 4, right, then I'll be writing like this. It's going to be x to the power of 4. Well, the first coefficient is 1, so I don't write 1 in the beginning. It's 1 times x to the power of 4. It means nothing, right? So it's x to the power of 4. Then I go like, of course, not this one, right? Then I go like 4x cubed y. Now what happens here is I actually start with x to the power of 4 times y to the power of 0, which means 1, right? That's why I don't write anything here. I just write x to the power of 4. Then I decrease the power of x by 1, so it's x cubed now, and I increase the power of y by 1, which becomes 1 here again, I don't write that because y to the power of 1 is just y, right? And then I keep on going. I say now it's 6 here, the third in line, so it's going to be 6. I decrease the power of x by 1, so it's x squared, and then increase the power of y by 1, so it's y squared, and then plus, next coefficient is 4, so it's 4x y cubed, and then the last one, right, it is y to the power of 4. X disappears as it goes like x to the power of 0, which is 1. So that's the expansion of x plus y, the brackets to the power of 4, right? So x to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the power of 4. So you can use Pascal's triangle by expanding binomials. You don't need to memorize these numbers. You can just build Pascal's triangle on your own, and then you just go like this is the first row, x plus y, second row, third row, fourth row. See, these are the powers, as you can see, right, with the row numbers, right? And then you can just use these coefficients and follow the rule that you just decrease the first term's power by 1 for each term, and then increase the second term's power by 1 in each term, and you'll just get the expansion. Now let's look at this example here. In this binomial, you will notice that there is a coefficient here already, right? So we will just use this coefficient together with the coefficients in Pascal's triangle. Now let's have the Pascal's triangle first. So we will be using this row. Now how do I decide that? Well, you can just check with this second term, right? And when you match with the power, then that's the row you're going to be using. Now let's write the expansion. So I'll start with the first term. It's going to be x cubed, and then I'll get the coefficient here. It's going to be 3 times x squared. I decrease the power of x by 1. Now the second term appears as 2y, right? I'll consider all this as 2y, as one single term, and then I go on like plus again 3. Now it's going to be x, and it's going to be 2y squared, and then it's going to be plus 1, so it's going to be x. There's no x actually, right, because it's going to be x to the power of 0. So I'll be writing 2y brackets cubed. Now I have to simplify this further, so it's going to go like x cubed plus 2 times 3, 6x squared y, plus 2 to the power of 2 is 4, right? So I'll go like 4 times 3, which is 12xy squared, plus 2 cubed is 8, and it's going to be 8y cubed. So that is the expansion of x plus 2y to the power of 3. So what I do is I just consider this as one single term and make sure that I write the power using brackets for 2y in here and here. And then I just simplify it. Another example. Now it's 2x minus 5 to the power of 4. We'll be writing the expansion of this binomial. So the Pascal's triangle up to fourth row is as follows. Remember that you are adding these two numbers to find 3, and so on. You add these two numbers to find 6, and so on, right? So we go on like 2x minus 5 to the power of 4 equals, now I'll start with 2x to the power of 4 as the coefficient is 1. Now we have something different. We have the sign here. The sign is not plus anymore, but I will consider my expansion to be always in addition, right? So it's 2x to the power of 4 plus, now it's going to be 4 times 2x cubed, and then I will have minus 5 as the second term. And then I go like plus, I have 6 as coefficient, I have 2x squared, and then I have minus 5 squared, right? It's going to be plus 4 times 2x times minus 5 cubed, and the last term here will be plus, again the coefficient is 1, so I don't write it, and I don't have 2x as a term anymore. I'll have minus 5 to the power of 4. Now let's simplify this. So 2 to the power of 4 is 16, so it's going to be 16x to the power of 4 plus 2 to the power of 3 is 8. 8 times 4 is 32. 32 times 5 is 160. But just because that's minus 5 here, actually my sign will be minus here. So it's going to be 160 x cubed. Now, just because it's minus 5 squared, there won't be any minus sign. So I'll go like plus. Now, 2 squared is 4. 4 times 6 is 24. 24 times 25 is 600. So it's going to be 600x squared. And then just because this is minus 5 cubed, it's going to be a minus sign here. So it's going to be 4 times 2, 8. 8 times 125, 1000. And 1000x. And then the last one will be minus 5 to the power of 4, which will be 625. So that's the expansion of 2x minus 5 to the power of 4. Another example. The coefficient of x squared in the expansion of 2 minus cx brackets cubed is 294. Find the possible values of the constant c. Now this is binomial expansion question in reverse, right? So basically someone just expanded this, right, and then found out that the coefficient of x squared is 294, right? So we're trying to find the possible values of the constant c appearing in here. Now let's go with Pascal's triangle first. So I go like 1 1 1 1 2 1 1 3 3 1. So this is the row I'll be using because the power is 3, right? Now if I was to expand the expression in full, right, I would be writing 4 terms, but I need the x squared term. So the x squared term will appear here, because this is going to be x to the power of 0, x to the power of 1, x squared, and x cubed. How do I know that? Because this term is the second term. So the second term gets the power increased 1 by 1, right? So the x squared term will be this one, right? So I should be writing this term as 3, right? And then the first term here as 2, but just because it is here 2 cubed, 2 squared, 2 to the power of 1 and 2 to the power of 0, I'll be having 2 only as 2 to the power of 1. And then comes the second term, which is cx, but that's actually minus cx because there's a minus sign here, right? Minus cx squared, all right? That is the term we are looking for. So if I simplify this expression, it's going to be 3 times 2, which is 6, and then minus c squared is c squared, and x squared following it. So basically I have this term as 6c squared x squared. Now this, the question says, is equal to 294 x squared because it's the term with x squared, right? So if I cancel out the x squared expressions, I will end up with basically 6c squared equals 294. From here, c squared is 49, and then I'll have c to be plus minus 7. So that's the value of the constant c appearing in the binomial expansion. So basically this is pretty much it. You just expand the binomials, right, using Pascal's triangle, and then you can also find the coefficients of certain terms, or you can also find the unknown constant values given the coefficients of certain terms, right? So this is how we basically expand binomials with using Pascal's triangle. Thanks for watching.